Life on the International Space Station means no showers, no kitchens, and no beds. It is a constant battle with gravity's absence. Every drop of water, every crumb, every hour of sleep is tightly engineered and meticulously rationed. If these systems fail, comfort vanishes, and so does survival. How do astronauts actually manage to shower, eat, and sleep in a world where nothing stays put? On board the International Space Station, the laws of physics play out in unexpected ways. The station orbits Earth at an altitude of about 400 kilometers, moving fast enough that it is in a state of continuous freefall. This creates what scientists call microgravity. In this environment, nothing falls, everything floats. A drop of water released from a pouch will not trickle down or splash. Instead, it forms a perfect sphere, held together by surface tension, and it drifts wherever the slightest push sends it. Even a single crumb of food or a loose strand of hair becomes a hazard, free to float into sensitive fans or electronics. The absence of gravity means that everyday actions on Earth, pouring a drink, wiping a surface, even breathing, demand constant attention. Without gravity, warm air does not rise, so fans must keep air circulating at all times. If airflow stops, carbon dioxide can collect around a sleeping astronaut's head, making even rest a calculated task. Every tool, every meal pouch, and even the astronauts themselves must be secured by straps, clips, or Velcro. A misplaced object can quickly drift out of reach, or worse, find its way into equipment where it can cause malfunctions. Simple demonstrations, like squeezing a drop of water from a bag, reveal the strange rules that govern life in orbit. Liquids cling to surfaces or float in blobs. Debris never settles. It must be captured or vacuumed away. These physical realities shape every system on the station, from hygiene routines to the way food is packaged and consumed. Surviving in microgravity is less about adapting to a new view, and more about re-engineering the basics of daily life so that nothing is left to chance. Aboard the International Space Station, the simplest routines, washing up and eating, require careful engineering to keep both astronauts and equipment safe. Without gravity, a shower becomes impossible. Instead, each crew member receives a personal kit stocked with essentials: a toothbrush, toothpaste, a comb, a razor, and a compact supply of no-rinse soap and shampoo. To clean themselves, astronauts squeeze a small amount of water from a drink pouch onto a washcloth, add a dab of rinseless soap, and wipe down their skin. Hair washing follows a similar process, using only a splash of water and a towel to capture every drop. Any stray moisture must be quickly contained, since floating droplets can drift into electronics or ventilation systems. Traditional sinks are missing from the station. Toothbrushing, for example, means using just enough water to wet the brush, then spitting into a towel or swallowing the foam, because there is nowhere for wastewater to go. After each wash, towels and wipes are set aside to dry. Their moisture evaporates into the cabin air, where it is captured by the life support system for recycling. Meals are adapted to microgravity. Every food item is sealed in a pouch or container to prevent crumbs and spills. Tortillas replace bread because they do not shed fragments that could clog filters or float into delicate instruments. Drinks come in flexible bags with built-in straws and clamp valves, making it possible to sip without releasing floating droplets. Even utensils are designed with Velcro patches, so nothing escapes during a meal. The result is a daily routine that looks familiar on the surface, but every detail, from a splash of water to a bite of lunch, reflects the constant negotiation between human comfort and the realities of life in orbit. Inside the International Space Station, sleep is not as simple as closing your eyes. With no gravity to hold them down, astronauts must anchor themselves for rest. Each crew member has a small personal compartment, barely the size of a phone booth, lined with soft walls and equipped with a sleeping bag tethered to the wall or ceiling. There is no up or down, so bags can be mounted in any orientation, but the restraints are essential. Without them, a sleeper would drift aimlessly, bumping into equipment or floating across the module. The sensory environment is engineered as carefully as the physical one. The station orbits Earth every 90 minutes, exposing the crew to 16 sunrises and sunsets each day. To avoid constant disruption, interior lights are programmed to mimic a 24-hour Earth day, with gradual changes to simulate dawn and dusk. Still, the station is never silent. Fans and pumps run around the clock, producing a steady mechanical hum comparable to a vacuum cleaner. Earplugs are standard issue, and some astronauts use white noise to mask the sound. Air circulation is a matter of safety as much as comfort. Vents near each sleep station keep fresh air moving, preventing pockets of exhaled carbon dioxide from building up around the face. The result is a sleep experience shaped by restraint, routine, and the unceasing presence of the station's systems. Even at rest, discipline and design hold the environment together. Every day on the International Space Station is mapped out in fine detail, with the crew's time divided into 5-minute blocks from wake up to lights out. Among the most important items on the schedule is exercise, a medical requirement, not a luxury. Astronauts spend 2 hours each day using specialized equipment designed for weightlessness. The treadmill, for example, uses harnesses and bungee cords to keep the runner in contact with the belt, while the cycling machine secures the feet and leaves the rider floating above the pedals. The Advanced Resistive Exercise Device, called ARED, simulates weightlifting by using vacuum cylinders and flywheels instead of dumbbells. This daily regimen is not about fitness or personal preference. In microgravity, bones and muscles quickly begin to weaken, and without regular loading, astronauts can lose 1 to 2% of bone mineral density every month. Even with strict adherence to exercise, some loss is inevitable. Flight surgeons on the ground monitor data in real time, tracking performance, bone scans, and muscle mass. As one flight surgeon explains, exercise is a prescription. We are fighting the effects of space on the body every single day. The cost of survival in orbit is measured in sweat, discipline, and hours spent just maintaining a baseline of health. Water on the International Space Station is managed with a precision that leaves no room for waste. Every drop used for drinking, hygiene, or food preparation enters a closed-loop system overseen by the Environmental Control and Life Support System, called ECLSS. As one ECLSS engineer describes, the station is a machine for recycling the essentials of life. Up to 98% of all water is recovered, drawn from urine, sweat, breath, and even the humidity in the air. After an astronaut wipes down with a damp cloth, the moisture evaporates and is captured by air handling units, condensed, then routed through a series of filters and chemical treatments before returning to the potable water supply. The same attention to detail applies to waste. Toilets use airflow instead of gravity to collect urine and feces, separating liquids for processing and storing solids in containers that are eventually burned up in Earth's atmosphere. Sensors and monitors track water quality at every stage, flagging any deviation for immediate action. If a filter clogs or a processor fails, backup supplies and contingency procedures are activated within minutes. On the International Space Station, survival depends on systems that recover, recycle, and monitor with near-perfect efficiency, because resupply is measured not in hours, but in months. Life on the International Space Station is often imagined as a high-tech adventure, but the reality is closer to industrial shift work carried out in extreme isolation. The station's interior, though the size of a large house, is divided into narrow modules packed with equipment, leaving each astronaut with little more than a phone booth for privacy. Crew members share nearly every waking moment, working, eating, and exercising in constant proximity, with only brief escapes into their personal quarters. In this environment, solitude is rare and privacy is a luxury. To cope, astronauts rely on a mix of discipline and small rituals. Scheduled video calls and email provide a lifeline to family and friends on Earth, helping to bridge the emotional distance. Personal routines like listening to music, reading, or looking down at Earth from the cupola offer moments of normalcy. Crew members often mark birthdays or holidays with shared meals, using food as a way to reinforce team bonds. These practices echo life in other isolated, high-risk jobs, such as submariners beneath the ocean, oil rig workers at sea, or scientists overwintering at polar stations. Each group faces the same fundamental challenge, maintaining mental health and team cohesion while performing demanding work in a confined, hazardous environment. On the ISS, astronauts are not just explorers, they are extreme workers, navigating the delicate balance between technical precision and psychological survival. Every system on the station measures our limits of body, mind, and engineering. As we plan for missions to the Moon and Mars, the lessons forged in orbit shape how and if we endure beyond Earth. Survival in space isn't guaranteed, but discipline and design make it possible.